ladder is leaning against the side of a house, 12 meters above the ground. If the base of the ladder is 5 meters away from the house, how tall is the ladder? Well, the good news is, on most of the problems that we do here in geometry, the picture's provided for us. The bad news is it's not provided on this one, and even worse news is that means I have to draw the picture. But I am not a fancy artist here. I'm going to say there's the side of the house. And the ladder is leaning against the house. So there's the ladder leaning against the house. 12 meters above the ground. If the base of the ladder, so this is really not drawn to scale, if the base of the ladder, and the base is here, is 5 meters away from the house, and a ladder is leaning against the side of the house that's 12 meters high, what we want to know is how tall is the ladder. So I'm going to call this missing side C, and we don't even need to do trigonometry on this. We're just going to use our Pythagorean theorem. 5 squared plus 12 squared equals C squared. And we get 25 plus 144 equals C squared. And 25 plus 144 is 169 equals C squared. And use decimals, use your calculator, but we can take the square root of both sides. And that's going to give us how tall the ladder is, which in this case is 13 meters. The nice part is we were given two sides of a triangle, so we didn't need to use the trigonometry. If we're only given one side of the triangle and an angle, then we're probably going to have to use sine, cosine, and tangent to help us find what we need to find. And the above example involved using the Pythagorean theorem to solve a problem, but we can also use trigonometric ratios to help us solve. First, we need to discuss a little bit of vocabulary. And there's two types of angles that we deal with in the application problems. They're called angles of elevation and angles of depression. If you're elevating, what's happening is you're going upward. So you're looking upward for an angle of elevation. And depression then is going to be the opposite of that. We're going to be looking downward. And we have pictures up here, the angle of elevation to the left and the angle of depression to the right. The thing about the angle of elevation and the angle of depression is that they're formed with a horizontal. So over here at the angle of elevation, our horizontal line there, and in the angle of depression, our horizontal line is up, and we're looking downward. But there's one nice feature between the angle of elevation and the angle of depression, and that is that they're equal. The angle of elevation is always equal to the angle of depression because they, didn't even see that, they are alternate interior angles. So you can't see this picture very well, and I cannot enlarge it. But what we've got is we've got a line here and a line there. There's our two horizontal lines. And the angle of elevation, we're looking up. Angle of depression, we're looking down. But it's two parallel lines cut by a transversal. And what we said about two parallel lines cut by a transversal is we said that alternate interior angles are equal. And although we can't see it that well, I think it says 38 degrees. We've got a 38 degrees up by the angle of depression. We've got a 38 degrees down here by the angle of elevation. So it's because of alternate interior angles that we can use this equal idea. I probably should have said congruent, but you get the idea of how it's working. So let's take a look at some examples. It says, from the top of the fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. If the tower is 45 feet in height, how far is the partner from the base of the tower? to the nearest foot. So watch out for the rounding part of it. So this one's to the nearest foot. The nice part is the picture's already given to us. And in this particular picture, it even has labeled what we need to find. We want to know how far is the partner from the base of the tower. We want to know this X length right there. So our angle of depression is 40 here. But again, a horizontal line, another horizontal line, two parallel lines cut by transversal. That 40 degrees that I have marked is also 40 degrees here. And now we have a right triangle that we can look at to write our trig ratio from and actually figure out the value of x. So we're going to take the 40, and across from the right angle is the hypotenuse. Across from the 40 is our opposite, which means that our x is the adjacent. And we know the opposite. We want to find the adjacent, and the function that's talking about, that deals with opposite and adjacent, is the tangent function. So this is going to be the tangent of 40 equals the opposite divided by the adjacent. When the value is, what did I say? Down low, we need to have switch a row. When the value is down low, we need to switch a row. In other words, what's going to happen to solve this is we're going to switch the x with the tangent of 40. And then we're going to type that into decimals. (45) divided by tangent of 40, tangent of 40, and we can see the value right there. 53.62. We want to round to the nearest foot, but let's put that back in there, 53.6 for now. X equals 53.6. But our directions again tell us round to the nearest tenth of a foot. I even misread it. So we just did round to the nearest tenth. The value of 2 after the 6 is less than 4, so the 6 is going to remain the same. So again, if we know that sine is opposite over hypotenuse, if we know that cosine is adjacent over hypotenuse, if we know that tangent is opposite over adjacent, then we have a good start on how to set these up. And again, nice to have the pictures, goofy as they may be, like this one. But it says the ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. Again, all that stuff is labeled for us. It says find to the nearest degree the angle that the ladder makes with the wall. So remember, when we don't know the angle, it's not a curse. We just have to use the inverse. So what we're trying to find, and it's labeled for us, we need to find this value here of x. Well, let's label our triangle. And as we go across the right angle, here's the hypotenuse. We want to find angle x, so if we go across from x, that's going to be our opposite, which means that the 15 is the adjacent. And once again, when we set up our trig ratio then, what function relates opposite and adjacent or adjacent and opposite? It's the tangent function. So the tangent of x equals the opposite divided by the adjacent. So we need to use the inverse button when we flip over here to Canvas. And the inverse button, go to the functions. It's going to be tangent to the -1. And then our ratio is 6 divided by 15. And it calculates us for us here 21.80. Let me be a little bit better here. If we're rounding to the nearest tenth, we're going to look at that 0 to round the 8. We'll have to go back and look at what it's asking for again. But 21.8 is what this would be initially here. And then it says find to the nearest degree. Well, since it's 0.8, 8 is 5 or higher, we're going to say 22 degrees for our answer on this particular one. It's super helpful to have the pictures to figure out our values here. Hopefully you're doing pretty good with these because they get a little bit more complicated, as this next one is. It says, Olivia is in a lighthouse on a cliff. She observes 2 sailboats due east of the lighthouse. The angles of depression to the 2 boats are 33 degrees and 57 degrees. Find the distance between the 2 sailboats to the nearest foot. We're going to have 2 setups for this particular problem. And just take a close look here. I have a pretty decent picture. I can make it a little bit bigger. But we've got a right angle with triangle CDA. And then the other triangle that we're going to be looking at is we're going to be looking at the triangle CDB. And eventually what we want to do is we want to find the distance between the 2 sailboats, between sailboat A and B. That's what we're looking for eventually. But let's start by finding the distance from D to A. And we've got angles of depression in this one, and remember that 2 parallel lines cut by transversal, alternate interior angles are equal. If this angle here is 57, there's the transversal. I went to here, that's pointing to the transversal. That means that this angle right there is also 57. The horizontal at CE, the horizontal at DB, and then the alternate interior angles. So now we know an angle, they're in a triangle, and eventually what we're going to be trying to find on this one is we're going to try to find the length of DA, which I'm going to call X. So we're going to label our triangle, and we've got across from the right angle here is the hypotenuse. Across from the 57 is the opposite, which means that the X is the adjacent. We want to find the adjacent length. We know the opposite length, and we need one more thing before we set this up, besides the fact that which function relates opposite and adjacent? Well, it's going to be the tangent function. But the other piece of information that we need here is we want to find the distance between the cliff and the lighthouse. And it's labeled, but the height of the cliff is 110, and the height of the lighthouse is 85. So 110 plus 85 is 195. And that's the length from C to D, right there. And we need that whole thing. Now we have everything we need, at least for this triangle here. Tangent of 57 equals the opposite, which is the value we just found, 195, divided by X. And again, when the missing variable is down low, we need to switch a row. In other words, what needs to happen is the 195, the X, and the tangent of 57 need to change places. And we're going to figure out what that value is by typing it into decimals. 195 divided by tangent, just tangent, not an inverse there, tangent of 57, and we get 126.63, and we're going to round to the nearest tenth. So we're looking at the 3 to determine how to round the 6. 3 is 4 or less, so it's going to be 126.6. But that's not all we have to do. We have to do 2 parts. And as we go back and look at the directions again, it says find the distance between the 2 sailboats to the nearest foot. So 126.6 is going to really be 127. And now we have to find another distance. And what I'm going to recommend is, well, we're going to use the 33, first of all. And 33 goes, without the orientness, goes to here. And what it's touching there is it's touching that transversal. So 2 parallel lines cut by transversal means that this angle here is 33. We're still going to use the distance from the top of the White House down. So we're still going to use the 195. But what I'm going to do is, instead of X here, I'm going to try to find that entire length right there. And I'm going to call it Y. So when we set this up, we need to label. Our opposite is appropriate. Across from the right angle is the hypotenuse, which means that the adjacent is also labeled appropriately. And when we set up the second part of this, this is going to be tangent of 33 equals 195 divided by Y. And because the value is down low, we need to switch a row. So tangent of 33 and Y are going to switch places. So we get Y equals 195 divided by tangent of 33. And that's what we're going to type into decimals. 195 divided by tangent on the functions of 33. And we get 300.27, but we need to round to the nearest foot, so it's going to be 300. So Y equals 300. Well, let's go back and look, because there's one more thing that we need to do on this particular problem. It says find the distance between the 2 sailboats. Well, from D to B is the value we just found. It's 300. The first value that we found was 127. And if we subtract these 2 values, we will get our distance that they are apart. 300 minus 127. Sorry, 300 minus 127 is 173. And let's look at the units here real quick. So, feet. 173 feet apart. So I know I turned off the lights. It's warm in here and the sun puts a glare on the board, which is why I turned off the lights. Are we doing okay so far? Should we save the last one for Monday? Okay. It kind of looked that way. But try to work on some practice this weekend. I have it done. I've got that listed as after school to go scan. I don't have that on Canvas, and I don't know. My Canvas unit this time is kind of a mess. But we'll save the last one for Friday. If you're struggling with a calculator or Desmos in terms of putting it in degrees, let me help you with that at least before we go home for the weekend. believe that a blimp hovers above the ground at a height of 1,150 feet. An observer at point A sees the blimp at an angle of elevation of 24 degrees, while an observer at point B sees the blimp at an angle of elevation of 38 degrees. What is the distance to the nearest foot that separates the two observers? Well, once again, we're going to have to set up a trig ratio. And if I look left in the picture, we've got our angle of 24 degrees here. And ultimately what we want to do is we want to figure out what this distance here is. As we label this triangle, here's our hypotenuse. Across from the 24 is our opposite. And then that means our x is the adjacent. And once again, we know the opposite. We want to find the adjacent. So we need to figure out the value of x using the tangent function. So this tangent of 24 equals 1150 over x. And when the variable is down low, we need to switch a row. So we're going to rewrite this as x equals 1150 divided by tangent of 24. And that's what we're going to type in the canvas. 1150 divided by tangent of 24. And we get, I got out of Canvas here for a second, so I'm going to have to go back and figure out the degrees. So let's get out of degrees, get into degrees. So it looks like it fixed it right away to the 2,582.94. So let's say that's 2,583. I think we have to round to the nearest foot. What is the distance to the nearest foot? So for this part here, again, we get 2,583. And I'm going to look back one more time and check to make sure. 2,583. Well, not only do we have to find that distance, but we need to look at over here. Because we're going to ultimately figure out the distance from point A to point B. So we're going to set up a function. The opposite is still correct. Our hypotenuse now is here. It's going to make this length the adjacent. And I'm going to call that length y. So when we set this up, it's going to be the tangent of 38 equals the 1150 divided by y. And again, when the variable is down low, we need to switch a row. So this is going to become y equals 1150 divided by tangent of 38. And then we're going to go over to decimals. We're going to type that in. So 1150, oh, not there. 1150 divided by tangent of 38. And that gives us 1471.9, so I'm going to say 1472, because we have to round to the nearest foot. And then lastly, what we need to do is we need to take those two values, because this distance from A to here is 2,583. And the distance from here to here is 1,472. So we need to add those together. 2,583 plus 1,472. 25, oh darn it, 2583 plus 1,472. and 72 gives us 4,055. 4,055 figure feet.